Welcome to the Origins Science Scholars Program of the Institute for the Science of Origins. The Institute is a partnership of Case Western Reserve University, the Cleveland Museum of Natural History, and IdeaStream. The Fall 2014 Origins Science Scholars Lectures are presented with the assistance of the Siegel Lifelong Learning Program, the College of Arts and Sciences, and MediaVision. Tonight we are pleased to be here at the Tinkham-Veal University Center on the campus of Case Western Reserve University for the 7th lecture in this fall's 2014 Origins series, The Origins of Cuisine, with Professor Alan Rocke. Professor Rocke is Henry Eldridge Bourne Professor of History and Distinguished University Professor at Case Western Reserve University. He's a Fellow of the American Association for the Advancement of Science and of the American Chemical Society, which awarded him the Dexter Award for Outstanding Contributions to the History of Chemistry in 2000. He's the author of 4 books and numerous articles on the history of science, especially chemistry. Among the courses he has taught in his 37 years here at CWRU is food and history. So it gives me great pleasure to welcome Dr. Rocke for the Origins of Cuisine.
Last week, Dr. Scott Simpson talked about the origin of human food. And so my topic, the origin of cuisine, intersects nicely with his, and I think you'll find my comments complementary to what he said last week. So what I want to talk about is origin of cuisine, and to talk about that I have to tell you a little bit about the transition from hunting and gathering societies to farming societies, the invention of agriculture. There is a famous quotation about mankind in the state of nature by Thomas Hobbes in his classic work Leviathan, 1651. Mankind in the state of nature lived a solitary, poor, nasty, brutish, and short life. Well, it seems that modern science has shown that Thomas Hobbes was wrong about much of what he said. If you examine hunting and gathering societies, both contemporary and historical, what anthropologists have found, for one thing, is that all such societies use fire daily. They cook much of their food, and they eat commensally, which is a $10 word of saying they eat socially, they eat together. Does this mean that hunting and gathering societies have a cuisine? Well, I'm not sure about that, and maybe we can talk about that more in hunting and gathering. Part of the problem about deciding that question is evidence. That is, we don't know that much about cuisine, hunting and gathering societies. There was an English humorist who wrote an essay, a dissertation upon roast pig about almost 200 years ago, in which Charles Lamb discusses the question of the origin of cooking and fire. He tells the story, of course it's a humorous, satirical story, about a family in China eons ago, before cooking was invented. And the father was a swineherd, and he left his son alone in the house. And the son was playing with fire, and the house burned down. There were piglets inside, and so this was the first time that food had been cooked, according to this story. And his father was very angry when he came home and saw that the house was no longer there. But he tasted the roast pig for the first time in human history, and he liked it. So they rebuilt the house, and he cleverly allowed his son to burn down the house again so that they could have more roast pig. And neighbors tasted this and liked it, and they burned down their houses too. And this became a fad until somebody realized, well, it's not necessary maybe to burn down the whole house. You can have roast pig without that. That's humor, of course, but Richard Wrangham, who is an eminent primatologist at Harvard University, published a book 5 years ago on a similar subject, and his argument is, and this takes off from what Scott Simpson was saying last week, that human beings are not well designed to eat raw food. And Wrangham argues that they're so well designed to eat cooked food that in fact they are evolutionarily designed that way. And in fact, Wrangham's thesis is that the actual control of fire and the invention of cooking goes back far earlier than most paleoanthropologists have argued up till now. That is about 2 million years ago. That is when Homo erectus was first evolved. And so Wrangham argues that cooked food is essential to what we argue is humanity. That is, our physiology is designed to operate only on cooked food. We have small mouths, small teeth, weak jaws, short guts, and a very expensive brain, metabolically expensive brain, and all of that requires a high quality food. And high quality food means cooked food. Cooked food is nutritionally dense, it's easy to eat, it's fast to eat, easy to digest, and so on. So this is what Wrangham has suggested. But let's get back to this question of hunting and gathering and the transition between hunting and gathering societies and the first farming societies, the invention of agriculture. Hunting and gathering societies do have disadvantages. They're powerfully dependent on homeland ecology and the stability of that ecology. Even under the best conditions, the prosperity of the society often waxes and wanes. And above all, it's predicated on low population density. So it requires a large hunting and gathering ground and not very many human beings for that territory. And low population density correlates to low power of the corresponding society. So there was incentive to develop agriculture. In a state of nature, food for human beings is relatively rare and hard to find. It's been estimated that most natural environments have biomass all over that is theoretically edible, but not practically edible. That is, 99.9% of natural biomass is not really appropriate for human food. It's indigestible or hard to eat or hard to find or poisonous. Agriculture, the whole idea of agriculture is to boost that 0.1% of biomass around you that is edible up to 50% or 60% or 80% or something like that. And that's the whole idea about agriculture. It certainly makes sense. Farming societies can increase their population densities something like 100 times over that of hunting-gathering societies. And as population density and division of labor grows, so does the power of the society. So farming societies automatically became far more dense and hence far more powerful, and they were able to overwhelm neighboring hunting-gathering societies. And so there was a kind of a reinforcing cycle that went on. Farming then, therefore, led to what some have called an urban revolution. That is, villages turned into cities, cities turned into city-states, city-states turned into empires. We have what we call civilization. In the early Fertile Crescent, societies grew. Uruk and Susa in Mesopotamia, Memphis and Abydos in Egypt. These societies then were able to take advantage of divisions of labor. Of course, you had farmers, but no longer did you have everyone seeking food every day. You had the ability for farmers to support a large number of other people who were not farmers: soldiers, artisans, priests, scholars, an aristocracy, kings, and, of course, cooks. And so this I would argue, is the origin of at least what we know as cuisine, the culinary arts. This all happened first in the Fertile Crescent, which is an area, everybody I think is familiar with this. It was named about 100 years ago by James Breasted and includes Mesopotamia and the Levant, and some people also include Egypt and Anatolia. So the Fertile Crescent was the first part of the globe that developed farming, some centuries ahead of China, which was the second. I'm going to lay most of my emphasis on the Fertile Crescent for the simple reason that it's most known what happened in the Fertile Crescent, and I know most about this story. So how did this transition to farming actually happen? It was far more complicated than people know. There were nomadic farmers and settled hunting-gathering people. That is, you think of hunting and gatherers as essentially nomadic, but sometimes there were actually villages, settled villages of hunter-gatherers. By the same token, you think of farmers as intrinsically settled, but there were and are nomadic farmers. In 1967, this is a famous story, it actually happened. A botanist by the name of Jack Harlan harvested 4 pounds of wild einkorn wheat in 1 hour using a flint sickle. And this was to demonstrate that a hunting and gathering society, this was wild wheat he was gathering. A hunting and gathering society could manage quite well. That wheat could be used today or tomorrow or in 6 months, and it would grow back in the next season. So you could actually have a village sustained on wild wheat. There were, in antiquity, there were herds of wild gazelles in the Fertile Crescent, and there were, as I say, settled villages of hunter-gatherers. But a shifting ecology and depletion of wild foods may have pushed some of these hunter-gatherer groups towards farming to secure more certain food supplies. Well, one can argue that hunting and gathering was in some ways better than early agriculture. Early agriculture made less sense in some respects than hunter-gatherers. On average, compared to hunter-gatherers, farmers suffered greater malnutrition, they worked harder, and they had less leisure. And the consequent crowding of cities, these cities that I talked about, led to increased epidemics of diseases, as well as gender inequality and class divisions. Archaeologists and paleopathologists can trace the transition from hunting and gathering to agriculture by a significant reduction in overall height and other markers. The diets of early farming communities had less protein in general, less variety, more reliance on a single starchy staple than hunter-gatherers did. Well, how do we know all this? Scott Simpson told you a little bit about the material on this slide, but let me quickly summarize. Different food plants, different kinds of food plants utilize distinctive metabolic pathways, photosynthetic pathways in taking the carbon dioxide and water and making sugar and other materials from it. These pathways produce distinctive ratios of stable isotopes in the plant's tissues. And when those tissues are eaten by animals, those characteristic isotope ratios are deposited in the tissues, including the bones of the animals. So by analyzing the stable isotope ratios, you can tell what the animal ate, and that includes human animals. So this is all recorded in bones, and archaeologists and paleopathologists can retrieve those bones and carry out these analyses and discover what these creatures, including human beings, ate. Let me just conclude this portion of the talk by telling you a little bit about a recent discovery that relates to all this. The skeleton of King Richard III of England, who died in a battle in 1485, his remains were recently discovered. This was in the city of Leicester. It was traced to a former Franciscan friary that used to exist there. They didn't know exactly where the friary was, but they determined its location just in 2012. And they began to dig where they thought the church was. It turned out to be a parking lot in the city of Leicester. This is a report from the Washington Post. To see how Richard III's diet evolved, researchers from the British Geological Survey and the University of Leicester analyzed the chemical isotopes in 2 teeth, a femur, and 1 rib from his remains, discovered under a parking lot in Leicester in 2012. He consumed the equivalent of a bottle of wine a day, plus enough beer to total about 3 liters of alcohol. And his diet wasn't just heavy in the normal variety of meat, fish, and fowl, typical of the nobility. He feasted on a rich array of luxury foods, including swan, egret, and heron. Well, I think it's just amazing that you can tell that much about the guy's diet by analyzing his various bones. His teeth give you a record of what happened in the man's childhood. The femur gives you a record of what happens 5 or 10 years ago. And the rib bone gives you a record of what happened just a few months ago. Well, this is the report from the Washington Post, a reputable newspaper. There is a tabloid newspaper in London called Metro, and they distilled all of this into a single phrase, and I think it's quite well said. Richard III drank 3 liters of booze a day. No wonder he was found dead in a car park.
As far as the booze is concerned, what about beer and wine as a motivational factor for farming, for agriculture? I had read somewhere that that was a factor in people settling down because you couldn't get all the necessary ingredients naturally.
You're going to hear this from me in a few minutes.
Oh.
Yeah. So, very good question, but you're gonna hear a lot more about it in a few minutes.
So the move from hunter-gatherers to agriculture resulted in a more dense population, and yet you said that the more dense population had malnourishment and lost height. That seems to be contrary to each other.
Yeah, I mean, it is a paradox. But the point is this: hunters and gatherers were able to subsist on a wide variety of foodstuffs. They ate, in general, more protein. They had a greater variety. Farming societies, most of the people in farming societies ate poorly because they were dependent upon what those farmers were growing. And those farmers were growing basically 1 or 2 or 3 crops. So they were subsisting on a smaller number of basic foodstuffs, and basically they ate poorer. There were more of them. That gave the society power, and that power meant that farming societies overwhelmed hunting-gatherer societies.
But why were there more of them if their diet was poorer?
There were more of them because a few farmers could feed more people. I'm going to say more about this and why grains were particularly important. But a few farmers could then, I mean, if you're in a hunting and gathering society, everybody has to mostly look for food, find food every day, or prepare food. So it's an occupation of almost everybody. In a farming society, it's an occupation of some of the people. And those farmers could then feed everybody.
Could you speak to the differences between the advent of pastoralism as opposed to settled horticultural agriculture?
Yeah, I haven't said much about the development of livestock. And I intend to do that in the second portion. So if you still have a question after the second part of the talk, come back at me.
When you have only a few doing the farming, what does this say about the physical abilities? You no longer have fleet-footed, fast runners, hunters.
Yeah.
What does this say about the mental as well as the physical properties?
It does have implications, absolutely. I mean, we live in a society that is based on agriculture. We all do, ever since the transition to farming. And, you know, average athletic ability, especially the ability to run, is not the same as mankind in a state of nature. That's absolutely right. It changes our habits, our physical endowments, absolutely. And sometimes not for the better.
Thank you for joining us. You have been watching Dr. Alan Rocke discussing the birth of agriculture. For more information on the Origin Science Scholars Program, including a full video archive, please visit the Institute's website at www.case.edu/origins. In the next part of the talk, Dr. Rocke tells us why agriculture emerged first in the Fertile Crescent of the Middle East. Now, back to the talk.
Why the Fertile Crescent was uniquely favored. And I'm going to take much of the material from this talk from a book which many of you may have read, Jared Diamond's book, Guns, Germs, and Steel. So for those of you who have read that book, you will find much of what I'm about to say familiar. And I do want to concentrate on the Fertile Crescent rather than other parts of the world, although I will say something at the end of this portion of the talk about the rest of the world. So the so-called founder crops, those food crops that were pioneered in the Fertile Crescent, beginning about 10,000 years before the present day, included 2 grains, wheat and barley, and 3 legumes, lentils, peas, and chickpeas. And this was a nice package for early farmers because all of these crops had good nutritional value. And in particular, the grains and the legumes have complementary proteins so that they provide a decent nutritional package. I'm going to concentrate my comments the next 10 or 15 minutes on wheat and barley, the 2 principal grains of the Fertile Crescent. And I want to make a point about the importance of grains in general in the history of food. Grains are the oldest cultivated crops. All civilizations were founded on grain agriculture. And even today, they're crucially important. 70% of global cropland is currently devoted to the cultivation of cereal grains, and more than half of global calories today are consumed in grains. And furthermore, domestic animals, livestock, are also fed primarily by grains. And one can ask why were and are grains as dominant as they are? Well, first of all, in nutritional composition, grains generally have 80%, roughly 80% of digestible carbohydrates, and something like 8 to 15% protein plus vitamins. They are fast-growing and productive annuals. This is actually an important point. It's much more difficult to establish productive, supportive agriculture based on perennials. Annual plants put most of their energy not into growing stems and trunks and supportive structures for the plant, but into growing structures that will reproduce the plant in the next generation, which is makes it good for our food. Grains are easy to plant and to harvest. They are in a nutritionally compact form. If you think of wheat or any other grain, it's a heavy, dense collection of kernels. These are easily storable and transportable. You can have grain storage, and they will keep quite a long time. And this also makes them very valuable for basing a society on. I want to say something about domestication, because domestication of crops, food crops, and livestock is an essential quality of establishing a farming community, inventing agriculture. In fact, it's a sine qua non of inventing agriculture. But I want to make clear that domestication does not simply mean the routine human use of a species over years and centuries. It necessarily involves breeding, selective breeding of that food crop or animal for agricultural use. In other words, when you domesticate a food crop or an animal, you are altering its species, making it more appropriate as a source of food for the population. For example, if you think about elephants, elephants have been used for hundreds of years, for thousands of years, but we've never succeeded in domesticating the elephant. We've only tamed them. That is, we have not established a long-term breeding program for elephants that make them more appropriate for human use. As long as gatherers only gather from the wild, they exert little selective pressure. And I'll make this point clearer, I think, when discussing the most important grain, the king of grains, wheat. The earliest grains, and I mentioned them briefly a minute ago, were primitive wheats named einkorn and emmer. These are the wild versions of these two plants are the progenitors of regular wheat, of bread wheat that we know. Well, there are different kinds of wheat besides einkorn and emmer. Einkorn and emmer were the earliest, but these hybridized with sometimes known and sometimes unknown forms of other grains to form further kinds of wheats, including durum wheat, spelt wheat, and the wheat that forms most of the bread we consume today, bread wheat, or just wheat. The other pictures on this slide portray other cultivars of wheat. So let me explain how wheat was domesticated. The earliest wheats, the einkorn and the emmer, had grain heads that split apart at an unpredictable time when they were ripe, when they were ready to be replanted naturally. They were shattering grain heads or fruit stalks. And most plants are like that. They like to spread their seeds as effectively and unpredictably as possible. But this is bad for agriculture because you want to collect those seeds to eat them. And if they're constantly getting scattered individually by various plants, you're not going to succeed very well. So the early wheat farmers, those who were interested in developing wheat as a crop, did collect wheat, the grain heads, but tended to collect the ones that for whatever reason did not shatter. They were selecting for the non-shattering grain heads. And this diagram here shows several different sites, prehistoric sites. The one on the left dates from about 10,000 years before the present, when agriculture was just getting going in the Fertile Crescent. The one on the right is 6,500 years before the present. So you're going forward in time as you go left to right. And the green here indicates the percentage of shattering heads that were found in these archaeological sites. And you see that green is constantly diminishing as you go through time, and you get this purple, and the purple is the non-shattering form of the wheat. And so this is unconscious selection. The early farmers were basically gathering the wheat that made sense, the wheat that was still on the stalk, and by doing so, they were in effect doing selective breeding for a kind of wheat that made sense for early agriculture. So in the same way that they were selecting for non-shattering grain heads, they also selected, sometimes consciously, sometimes unconsciously, for grains that did not have a dense hull around it, makes it easier to thresh if they did not have the hull. For synchronous ripening, and you do that again unconsciously because you're harvesting and you want to harvest at one time, and you are unconsciously selecting for those varieties that do have this ripening all at once. More grains per head, shorter stems, larger grains, glutinous properties, which gives you better risen bread if you can do risen bread. This shows you, again, how lucky our early farmers in the Fertile Crescent were, because here's the distribution of wild einkorn wheat, the wild progenitor of domesticated einkorn wheat, and it goes all through Anatolia here, Asia Minor, and the emmer wheat tracks the Fertile Crescent almost exactly. So you can see that the wild versions of these plants that were then bred for food crops were nicely present, beautifully present in the Fertile Crescent. And this is why these particular crops were chosen. Well, let me now get to animals, to livestock. Livestock includes, well, dogs, sheep, goats, pigs, cattle, and horses, and all of these were domesticated in Western Eurasia from about 10,000 years before the present to 8,000 to 6,000. All of them were domesticated. And these animals, of course, give us a broad variety of things that we appreciate, that agriculturalists wanted. Meat, obviously, milk, companionship and service, fertilizer from the dung, power, especially cattle, transportation, and then materials, fiber, bone, leather, and a broad range of other materials. But not all animals can be domesticated. In fact, rather few of them are able to be domesticated. They have to have lots of favorable qualities, intrinsic qualities in the wild ancestor in order to make it possible for them to be domesticated. They have to have convenient and practical diets. They have to have a convenient and practical size and growth rate. This is why elephants have been hard to technically domesticate, because of size and longevity. They have to be breedable in captivity. Again, domestication means you put them in captivity and control their generations. And not all animals are possible to do that. And then wild ancestors have to be, or preferably ought to be, in herds or packs with a dominance hierarchy and non-exclusive territories. So what animal species best satisfy these prerequisites? Dogs, goats, pigs, sheep, cattle, and horses. And those were the livestock domesticated in the Fertile Crescent. And they are globally rare, such animals. Okay, so there were a wide variety of other West Eurasian domestications. I don't want to go through, I don't want to read this whole slide, but you can just stare at it for a minute. These happened after the founder crops. That is, between, let's say, 6,000 years ago and 2,000 years ago, all of these crops were domesticated. Let me say a few words about barley now. I've been talking about wheat. Barley is a good grain for making beer. And we know that beer was made early in this chronology, partly from the iconography that we can find. I'm going to say more about this in the third section of the talk. Here is a cuneiform tablet, which is actually a hymn to Ninkasi, the founder of the goddess of beer. And again, I needn't read this whole thing, but you can read through it quickly, this slide and the next slide. And it really constitutes a recipe for early beer almost 4,000 years ago. Well, the Great Lakes Brewing Company followed that recipe. This is a few years ago. Maybe you read about this, and brewed a Sumerian beer, which I did not have the pleasure of tasting, but you see the group on the left doing that, tasting it just as the ancient Mesopotamians did. Well, this gets to the point raised by the one gentleman. There was incentive to grow barley exactly for beer because you soak the grain, it turns into alcohol because the grain starts to sprout, and the sprouting turns into sugar, makes the starch turn into sugar. The solution turns sweet, it starts to ferment, and the obvious thing is to drink it. Well, I've omitted one factor here, and that is yeast. There is adventitious yeast all around us, and that yeast starts to grow in that solution. That's what makes it turn alcoholic, and the yeast then multiplies. And so in fact, drinking this early kind of beer would have been safer, cleaner, and more nutritious than actually just eating the barley that made the beer. And so there is an idea out there, it's been brooded for decades, that maybe it was exactly because people wanted beer that agriculture began. They wanted a steady supply of barley. So this is the point. I'll conclude with this slide. I actually have two more, but West Asia was uniquely favored because of the group of wild ancestors happened to be present in the Fertile Crescent. They domesticated everything that made sense to domesticate, and they were particularly fortunate in that sense. Okay, these are the last two slides for this portion of the talk. I just want to give you a global vision very quickly here. Agriculture also was founded in China with millet, based on millet and soybeans and rice. There was some agriculture founded in Africa based on sorghum, which is a grain, and yams and groundnuts. And then in the Americas, there was early agriculture based on some very poor crops, knotweed and maygrass and sunflowers here in northern North America, central North America, corn and beans, of course, in Mesoamerica, and potatoes and tomatoes in the Amazon. I just wanted to give you that quick global look of the other original sites of agriculture.
I see those arrows. Does that in any way indicate maybe a overuse of the land and depleting the soil and causing people to migrate? That
represents the spread of agricultural societies. And again, I want to point out, when a society makes this transition to agriculture, it means that the society has more ability to force its way on others. And so this is why agriculture tends to spread. This just indicates where it spread. From the original sites where agriculture was first founded in these various parts of the globe, and then where it spread. That's what the arrows indicate.
Were they ever aware of depletion of?
There were instances of, in the Fertile Crescent, actually the irrigation led to environmental issues. The land became saltier because of irrigation, but it was not so much depleting the soil. It was, there were other issues that came into.
You make no mention of fish. What about communities that lived by the sea?
I understand. Again, I'm not a personal expert. I don't do this research myself, but I understand that fish was unusual, that there were societies that it was established on the basis on riverbanks and by coasts and so on that relied on fish, but it was unusual. It was far less central than you might think.
When did chickens appear?
Yeah, that's, you're not going to hear me talk about chickens today. Chickens, the ancestral animal that became a domesticated chicken was a Southeast Asia jungle fowl. And this was domesticated very early, and not much is known about that process, exactly when or by whom. And then it spread from Southeast Asia to other parts of the globe. Eventually it did get to Western Eurasia, but late. That is, by classical antiquity, the Greeks and the Romans, they knew chicken. But I'm not going to go that far. I'm talking about the origin of cuisine in Western Eurasia. That's my real topic, and chickens were not there. Other fowl were. I mean, wild fowl, geese and ducks and so on. But domesticated chicken, no.
Is there a significant nutritional difference, either positive or negative, between Monsanto wheat, GMO wheat, and the ancient wheat?
Nutritional difference, everything I've read says no. There is no nutritional difference. GMO wheat, I mean, you have to compare like with like. So I would compare GMO wheat to a non-GMO wheat grown today, okay? That would be the best apples to apples comparison. And nutritionally, they're the same. There are issues of concern to reasonable people about GMO crops. But everything that I've read suggests that nutritional quality is not one of them.
When was the widespread use of spices started?
I'm going to talk about the two cuisines that we really know a lot about, the earliest cuisines that we know a lot about, which are in Mesopotamia and Egypt. And particularly in Mesopotamia, we know a great deal, including about spices. So I can't say that they were the earliest users of spices, and I'll talk more about this in a minute. But what I can say is that's the earliest use that we know anything about, that we can say anything as historical information.
I had like a more basic question. How did mankind first figure out how to eat cereals in the first place, right? You can't really eat it raw. You have to kind of thresh it, you have to process it, then eat it. Like how did, out of all the things growing in nature, right? How did they figure out that, hey?
People wonder how people came to eat almost anything. But the answer is they were trying, they were hungry. They were trying everything. And when something was good, they stuck with it. Now, grain is hard to eat, but you can fix that. You can soak it until it gets soft, until it starts to sprout. Then you have, essentially, the basis of beer. Or you can crush it. And it's not hard to find rocks to crush grain. And then you can eat the grain. What most people did, they crushed it and then they cooked it. That is, they made a paste from it and they put it on a hot stone. And that's a grain paste. And I'm going to talk more about that in a minute. But that's how people eat the grain.
We hope you've been enjoying the Origins Science Scholars Program with Dr. Alan Rocke. Dr. Rocke is a member and the founding director of Case Western Reserve University's program in the history and philosophy of science. In the second part of our talk, we learned about the Fertile Crescent and why agriculture developed there first. In our final segment, Dr. Rocke will tell us about the emergence of cuisine in Western Europe. Now, back to our talk.
Let's move on then to the third part of the talk, the birth of cuisine in the earliest West Eurasian civilizations. And we're going to start with Mesopotamia, and then I'll come to Egypt. Mesopotamian civilizations are studied by Assyriologists who read cuneiform texts. And although I love languages, I'm glad I never tried to decipher. That picture on the right is a kind of stylized and clarified version of cuneiform text. The Mesopotamian civilization had lots of different civilizations in it: the Sumerians, the Akkadians, the Babylonians, the Assyrians, the Neo-Babylonians, the Persians, and then we get to classical antiquity. The ancient Mesopotamian civilizations began as civilizations about 3500 BC, and this era extends to the classical era of Hellenistic Greek and Roman cultures. So that's the basic framework of Mesopotamia. It's, of course, modern-day Iraq. How do we know anything about Mesopotamian food? Well, first of all, archaeology. We dig things up and we analyze them and think about them, and that's not just bones, but artifacts and other things. We can examine images on stone reliefs, on cylinder seals, on wall carvings, and then we can see what they actually wrote, because these cuneiform writings have been decoded. This was in the course of the 19th century. There's this wonderful collection at Yale, the Yale Babylonian collection of cuneiform texts. The tens of thousands of clay tablets held at Yale University, one of the finest collections in the world of cuneiform texts, many of which have never been properly read. There are too few Assyriologists to do all that work. And even after decades, many of them are just sitting there waiting for cuneiform scholars to study them. Well, one collection was published in 1985 by a French Assyriologist by the name of Jean Bottero, and more about him in a minute. What Bottero discovered was a whole series of menus, food lists, recipes, and correspondence regarding food in these cuneiform texts. Unfortunately, there was little detail on actually how the foods were prepared. So the menus were basically ingredient lists. The recipes, that is, were ingredient lists. So here's some examples. On the top you see a stone relief of Ashurbanipal's banquet. He was an Assyrian king about 630 BCE. And on the bottom of the slide you see a cuneiform tablet that is, in fact, a recipe manual unearthed or translated and published by Bottero, and his book, La plus vieille cuisine du monde, the oldest cuisine in the world. So what was ancient Mesopotamian cuisine? It was largely barley-based. Barley was their favorite grain by far, but they also used wheat, emmer wheat. They knew how to make bread as well as beer. Beer was universally popular in Mesopotamian society across all of these civilizations that I named. But they also ate a variety of foodstuffs: chickpeas, lentils, beans, and millet. The onion family was highly popular. That, of course, includes garlic, leeks, shallots, and chives. They had a variety of animal food, livestock, lamb and goat, pork, until about 1000 BC, when pigs began to be regarded as unclean, and some beef as well. And then the list goes on. It's a long list: fish, shellfish, game, dairy, bakery goods, risen bread. They loved insects, fermented insects, grasshoppers, dates, pomegranates, nuts, greens, licorice, spices, and so on. One of the documents was a bilingual culinary dictionary that Bottero translated, about 4,000 years old. 800 items of food and drink, 100 soups, 300 breads, 20 cheeses, and on and on. We know a lot. Correspondence, here's an example. Good health, my brother. You know that for some time you haven't been sending me garlic, onions, or sirbitu fish. He didn't know what sirbitu fish were. I am sending you a personal name. Get for me, wrap it up, have him bring me for 8 units of money garlic and as many onions as well as sirbitu fish. And another piece of correspondence from 1700 BC. In the last caravan I was brought 100 liters of barley semolina, 50 liters of sesame seed, and so on. You see all these foodstuffs which you can read being named. But there isn't any ziktu fish. He didn't know what ziktu fish were. It's not clear. Send some to me so that I can make you some of that brine and have it brought to you. Here's a recipe: Carefully lay out the fowls on a platter. Spread over them the chopped pieces of gizzard and pluck, as well as the small sepetu bread. Again, he didn't know what sepetu meant, which have been baked in the oven. Sprinkle the whole with sauce, cover with the prepared crust, and send it to the table. Botero commented, "I wouldn't wish such meals on any save my worst enemy." However, I think that was unfair. He later said, "It is my opinion that in any given culture, imagination and refinement, whether culinary or otherwise, are by themselves easily contagious. I do not believe that the cuisine of even the most modest households is necessarily reflected in the sorry mushes and doleful mastications to which we Assyriologists have consigned them so sadistically." And I think that's a fairer statement. Well, one of the ancient feasts has actually been reproduced, and this is King Midas's funerary feast, 720 BCE. King Midas was the king of Phrygia in the town of Gordion in Anatolia. And when he died, they gave him a big party to send him off into the afterworld. And Patrick McGovern, who is a professor at University of Pennsylvania, he's been called the Indiana Jones of culinary archaeology because he also has a PhD in chemistry. And he scrapes the residue of these dishes that were left in the tomb and subjects them to high-powered chemical instrumentation and figures out what the food must have been in that dish. King Midas's feast consisted of a stew of lentils, barbecued lamb, maybe goat, and imported olive oil. The stew was flavored, here you come to spices, with fennel or anise and something peppery like bitter vetch or fenugreek. So in many cases, he could only narrow down the range of possibilities to a certain few. The mourners, at least 100 of them, as evidenced by the large number of quart-sized bronze drinking bowls buried in the mound, drank a brew of wine and beer mixed with mead, a sort of Phrygian punch. This, too, has been reproduced, and you can buy it. It's called Midas's Touch. And this is a beer. Unfortunately, the Great Lakes Sumerian beer is not available commercially, but this one is. You can go to Whole Foods, and last time I was there, you can buy it. It is kind of expensive, but it is seriously based on what they actually thought this Phrygian punch was, which is a combination of wine and beer and mead with curious flavorings. So these are some other pictures of some feasts, Mesopotamian feasts that have been reproduced for modern palates. Let's move to the final cuisine, Egypt. And just everybody knows a little bit about this, but Egyptian civilization was founded circa 3100. And for almost 3,000 years, there was a high civilization in the Nile River Valley. How do we know about Egyptian food? We can see visually the depictions of agriculture and of feasts, mostly in tomb paintings. We can do the archaeology, and there is actually a fair amount of relic food that has been found in tombs. Basically, the idea is to help the departed be fed in the afterlife. Much less textual evidence than is available in for the Mesopotamian case. But we do have much information on what they ate. Little information on preparation, recipes, or cuisine, less than in the case of the Mesopotamian food. So what was food in ancient Egypt? All of the Fertile Crescent foods, the so-called founder crops, but a particular emphasis on beer and the onion family. So garlic and flatbread was food for the poor, and if you were more wealthy, you could eat animals, beef and goat and lamb, pork. Again, early Later on, the pigs were, like the Mesopotamians, regarded as unclean by the Egyptians. Game, figs, dates, grapes. They made wine, and they loved risen bread, which is more characteristic of Egypt than Mesopotamia. There are, as I say, relic foods found in tombs, so we can actually, well, theoretically, you could taste this, but I wouldn't suggest it. So there's some dried fruits in the upper left there, a loaf of bread, one of these triangular loaves of bread, and you see these loaves actually depicted frequently in the tomb pictures. And on the bottom you see an actual piece of mummified beef rib, which has been subjected to the same mummification process that they applied to the body of the inhabitant of the tomb. And again, the idea was it's important for the departed to have a source of food in the afterlife. In my experience, the best displays of these relic foods are in the British Museum in London. They've got a lot of this stuff, and it's fascinating. I want to end the talk with just 7 conclusions. These are assertions that I would like to present to you for a discussion. First of all, I've tried to argue that cooking is as old as humanity. If you believe Richard Wrangham, cooking is what evolutionarily made us human. It spurred evolution to make us what we are. Number 2, cuisine is as old as the earliest civilizations, and I've tried to illuminate what these early cuisines are. As I say, there's this big unknown that they could even be older than the civilizations if you believe that hunting and gathering societies have cuisines. Distinct civilizations do have distinctive cuisines, but there are also many commonalities, as I hope I've indicated, at least for the region that I have chosen to highlight. And the last of my conclusions, food is a defining aspect of our species. Good food is universal. And I want to say cuisine celebrates both humanity and creativity. Thank you for your attention.
This lecture is part of the Origins Science Scholars Program of the Institute for the Science of Origins. The Institute is a partnership of Case Western Reserve University, the Cleveland Museum of Natural History, and IdeaStream. The Fall 2014 Origins Science Scholars Lectures are presented with the assistance of the Siegel Lifelong Learning Program, the College of Arts and Sciences, and MediaVision. For more information on the Origins Science Scholars Program, including a full video archive, please visit the Institute's website at www.case.edu/origins.